Hi, welcome to another video. And in this video, I'm going to covering about backflash, a very common phenomenon in gas chromatograph. And we will answer the question, how much is too much? Basically, what I mean is how much injection volume is too much when you perform the injection. Before I get started, please subscribe to my channel. And for those of you who are new to my channel, my name is Peter Tran, an engineer from Watson EC. Watson EC has been providing turnkey solution for lab GC as well as process GC for the past 35 years. So do check out our website at watson-ec.com and subscribe to my channel to find out more detail about us. All right, so let's jump back right into this topic for today, backflash in GC. All right, so let me show you a schematic of how the inlet will look like. So this is a typical split inlet where you have the septum, the orange color on top here. Then you have the liner with the gray color right here. And then you have the gold here at the bottom. Okay, this whole thing is so-called the inlet injection port, where you have the total flow rate, where you supply the flow rate going to here. Then you have a septum push, then you have a split fan out, as well as you have column flow rate from here, right? So when you first started the injection, you have, let's assume you do a syringe injection, and where you have some sample, I label them as a circle, the red circles inside here, and you perform the injection right into this liner over here. So what will happen inside is the sample you inject is typically is liquid form, and because we are doing gas chromatography, so everything should be vaporized into gas form inside the liner over here. So the vaporization process will actually depend on a couple of parameters. The first thing is the injection volume. How much the sample that you inject just now. So the more you inject, the more vapor you will see inside, right? That's the common sense. As well as the inlet temperature is the second parameter you want to look at. So the higher the temperature in the inlet, the more molecules you may be able to form inside, right? Then the inlet pressure, how much pressure inside the liner here to compress everything into the inside the liner here, as well as the solvent density and molecular weight or molar mass of the solvent that you have in your sample. And then the liner volume, of course. So how big is the the volume inside here, whether it will be able to contain all of your gas sample inside. So all of these factors will affect the vaporization process of your sample inside. So ideally, your sample should be fully vaporized and contained inside the liner like this. So that's where you have the total flow rate from the EPC. We eventually push the sample through the gold seal here and to the column eventually. So that's where you have a typical and successful injection. So everything will go smoothly as that. All right, but what if something happens? Let's assume that you inject a little bit too much of your sample. So which is the first scenario here, or you change off this parameter over here and causing the thing to happen. The phenomenon we call it backflash. So backflash, it's not backflashing, it's backflashing. Okay. So what happened with backflashing, I'm sorry, it's actually, okay, let's start the injection one more time. And then what happened with this one, if you inject too much of sample, some of the molecules will actually end up somewhere on top here. All right. Not all of them will be contained inside the liner, but some will end up on top here. And even worse, some of them may enter into the septum line over here. And once they enter the septum line over here, there's no way for them to go back because there's no flow rate to push them back. So that means you are losing some of your sample over here. So you don't get good reproducibility, you don't get good repeatability, and some of the sample will be condensed over here. Eventually, they may clog the line of the septum pouch as well. Right? Or even worse, that you have some of the molecules will end up somewhere here to the total flow from the EPC. What will happen over here is, because over here is not that hot compared to the liner temperature over here, because it's not hot over here, a sample may condense somewhere inside the line over here, and you keep running, and some of them may be pushed inside the liner eventually, but very slowly. So that way you may see gauge peak, carry over, and even restriction of the total flow rate. Sometimes you may even see like the flow rate is not able to maintain the pressure inside the liner because the flow rate is not correct anymore, something like that. So a lot of things would happen with this backflash phenomenon. So this is something is very, very common in gas chromatograph. If you don't validate if you don't develop your method correctly, you don't optimize your method correctly with all of this. So in this video, I'm going to show you how to do that correctly, and we consider all of this, but don't worry, it will be super easy because Agilent does provide a software so-called calculator to help you all of this. So you don't have to worry about all of this. So stick with me to the end and I'll show you how. All right. So the impact of the backflash you'll be seeing is repeatability and reproducibility, because basically the sample will not be able to fully contain inside a liner. So some of them will be retained inside over here, some will be over here, some will be on top here. So you are not able to reproducibly transfer your sample to the liner and to the column eventually. So that's where you don't get good repeatability and good reproducibility. The second problem you may have is a split peaks. So basically the peaks over here, your compounds, they are not distributed somewhere near each other like this. So let's say compound A, some of them are here, but for some reason, some of them are on top here as well. So some of the A compound, we eventually get to the column and to the detector. And then later, probably a few seconds later, you have some of the A compound will come along the way as well. So you have one peak, then you have a smaller peak, something like that. So that we call a split peak for this phenomenon as well. And you have gauge peak and carryover, as I mentioned before. Some of the condensation may happen somewhere over here, or along the wall over here, or on the O-ring over here. So that's where you have the condensation, and eventually you will have the gauge peak and carryover, right? Then the next one you might have is tailing peaks, of course, because the compounds are not fully contained inside the liner. So some will be here, some will be here. So the distribution band is much broader, and where you have the tailing peak, right? So the peak basically will be much broader than normal, right? So those are the very common phenomenon that you'll be seeing when you having the backflash problem. So how to avoid backflash? This is the next slide I'm going to show you. The first thing, of course, the 5 parameters I showed you up front just now. The first one is volume injection, of course, and you don't want to inject too much of your sample. So this is a very typical, I think, parameter that a lot of chemists or my customer has been using to improve the detection limit, or to improve the sensitivity of the analysis. So this is very simple, right? It's very obvious. To increase the sample injection volume, you should get more molecules, and that way you get more sensitivity as well as better detection limit. But if you inject too much, you may run into the problem of backflash, right? As I mentioned just now. The second thing is the inlet temperature. You don't want to go super high temperature. Of course, you don't want to go super low. The temperature have to be enough to vaporize your sample efficiently, but you don't want to go more than that. So let's say 200 degrees is good enough for your sample. You don't want to go to 250, because the higher the temperature, the higher chance you will have the backflash problem, because the sample will be vaporized a lot more, and that will cause a backflash. Okay, the next thing is inlet pressure. You want to have higher inlet pressure so that you can push all of the molecule, make them stay inside the liner, don't let them come out, right? So I'll show you. Let me go back to the diagram just now. So if you have high pressure in somewhere over here, which is inlet pressure over here, you have high pressure over here, the molecule will have harder time to get out of the liner, because you have like a bodyguard sitting on top here, like with high pressure. So if you have high pressure, the molecule will be more difficult to get out over here. All right. And then the next thing you want to have is, or you can do the pulse split, pulse pressure. I'll show you real quick in a few seconds. Right. The next thing you can consider is the solvent density. So most of the time we will dilute the sample into a certain solvent, and you may want to choose some solvent that have more density, that have a higher molecular weight, so that it will not vaporize so much, so you don't have that backflash problem. Okay, then the last thing you can consider is to use another type liner to have larger volume of the liner, so that it will be able to contain of your sample 100%. Right. So these are the factors you want to consider, and as I say, I will show you a tip in this video how to consider all of this in one go. You don't have to try and error with what's the injection volume should I try, what temperature should I try, all of these factors, right? So that will take a lot of time for you to do try and error. So in this video, I will show you that.